So talking about AI for ADAS and AD, right? You might be thinking about this perception, right? So you can use it for detecting the object, which is deep learning, machine learning, computer vision, image processing. You can use it for semantic segmentation to find open, the free space and etc. You can use deep learning, machine learning for, detecting the objects from the point cloud or from the, let's say, the automotive 4D radar, etc. So we have associated shipping examples, right? So this is one of the applications, and it's very obvious, right? Everyone knows, right? Okay, so deep learning, but the perception techniques for ADAS and AD looks like this, right? So, but there are more applications, I would say, that you can kind of use AI for, let's say with MATLAB and Simulink. Okay, so this is a typical example, right? Let's imagine this is AEB, right? So we have a plant model, we have the, let's say, the vehicle dynamics, we have the environment model, we have to control the AEB controller, we have maybe a more high level, let's say, this planning, scheduling system, and the sensing. Sorry. And one of the application is predictive maintenance, right? So predictive maintenance is using the AI techniques. It can be machine learning model, or it can be a deep learning model, right? To predict, when we should kind of maintain the let's say this physical, let's say engine, or this device, right? Or when we should kind of change it, or to predict, when the failure or the malfunction will happen. Okay, so this is predictive maintenance. And also in academia, I would say there were a lot of interest from academia on reinforcement learning, right? I also know, let's say, some automotive customers, they also have, let's say, this advanced research. I would say there's a team that they are doing some job on using reinforcement learning to beat the human driver in terms of, let's say, saving the fuels or increasing the performance, etc. Right? So that's reinforcement learning for control. And so this is a big part, right? Reduce all the modeling, right? So a lot of our customers, they are interested in using AI to generate or to create the reduce order model. I'm going to give you some more details later on. Okay. And the last application I'm going to introduce today is to use AI to create virtual sensors. Okay, so these are the different applications, right? It's in addition to, let's say, perception, right, for ADAS and AD. So before I introduce these examples, I'm going to maybe give you overview on what has been changed, in the industry during the past few years since AI is exploding, right? So first of all, and of course, how Matrix respond, in terms of creating a tool for our customers. First is there are more, I would say, much more types of models that are being used. So the Matrix response is that we are offering these kind of models for our customers, such as the regression models, let's say the support vector machines, which is from the machine learning and statistics toolbox, classification models, and the deep learning models. Okay. And the second thing which has been changed is that there are much more data than before, because for autonomous driving, we have much more data to handle, right? So MATLAB is good for handling big data, and we also offer different types of apps, the MATLAB apps, for you to handle different kind of this data, such as image, point cloud, and etc. Third, there are more tools from MathWorks that allows you to create models, such as the classification models, the classification learner app, the regression learner app, and etc. So these apps are mainly from machine learning and statistics toolbox or deep learning toolboxes. So these apps makes our life easier to create models, to train the models, to let's say to augment our training data sets, to visualize the result and validate the training. Okay, so let's have a look at how our how our customers use the AI. So BMW, they use machine learning toolbox to detect the oversteering. And Gaussian, they use the AI to estimate the battery pack states. And also we have customers, I think we have quite a lot of customers, they use AI for creating the virtual sensor model. Because what the sensor models are usually very complicated to model, especially for, let's say, this high order or nonlinear effects. So it will be very complicated to validate the model. So that's why. So I'm going to give you maybe a bit more details on how we adopt AI for different applications. First of all, as I said, there are a lot of interests from our customers regarding reduced order modeling. So why? Because let's imagine if you use the physics-based models such as Simulink, let's say that, right, to model the engine or the gearbox, right? And if this is a very high fidelity model, it can be very time consuming in terms of simulation performance, right? It might take a lot of time to simulate even, let's say, for a second simulation, because the model is very complicated, it's very high fidelity. So if the customer is interested in using this model for real-time testing, it can be a problem. Either that you use parallel computing or use a more powerful this high performance machine to perform simulation. And another path or another way to resolve this issue is to reduce order modeling. You can collect the data from the simulation model, right, or from the real world data, and then you can create a proper either, let's say, a machine learning model or deep learning model, right, a deep neural network. Then you feed this data to kind of train a proper model and replace the more physics-based models in the simulation environment and perform simulations. So you can still get a very high accuracy, but a fairly high simulation performance model. So this is one of the applications for reduced order modeling. Another one is is to use AI to create the virtual sensor models. So why? As written here, it is very expensive. It contains a lot of noise, and it is a time variant system, meaning that usually these physics or these chips or sensors will degrade in terms of performance over time, right? So it's very hard to have a proper like physics-based virtual sensor model, right? So and one of the solution is to use AI, is to use a model, a proper model, to so the same process, collect the data, and to train the model, and to predict the kind of these output or the measurement from a model. So yeah, so this is another example. Reinforcement learning is also, as I said, is also so we got a lot of interest from academia. So we have an example for autonomous driving, which is the automatic parking example. So here we have the so we use reinforcement control to replace the traditional controller. So as you can see, so we have the ego vehicle model, we have the sensor model, and we have the the reinforcement learning or the MPC tracking controller, right? And then we kind of visualize it, and it works, But of course, as I said, so we got some interest from academia, but we will still need to think about how we can use reinforcement learning for industrial applications. But this is another story. But reinforcement learning, since the core part of the reinforcement learning is first of all, it's the framework, right? It's a framework on so the network will, or the model will get reward when it is doing something right? But it is doing something wrong, then they will got kind of criticism. So so the core of the reinforcement learning controller is that there is some sort of the network, or maybe two networks there, which under this framework, it will automatically kind of get a reward and be better and better. So that's how the reinforcement learning control works. Okay, so to summary the AI, as I said, there are different applications in terms of perception, in ADAS and AD, reduced order modeling, virtual sensor modeling, reinforcement learning, predictive maintenance, right? So what methods offer in terms of the tooling is that we have mainly, the machine learning and the deep learning toolboxes as a foundation of the AI features that we offer. And according to different applications, let's say aero defense application, automotive application, automated driving, or communication, robotics, and etc. So we offer vertical toolboxes, which includes the AI applications as well. So for automated driving applications, we have the automated driving toolbox, the LiDAR toolbox, let's say the computer vision toolbox. All these tools, are for your reference, that allows you to create different, like this, let's say these AI models. We offer different shipping examples from these toolboxes, which include AI techniques. Okay, so I've finished the last topic. This is last slide today. So I think there are so many different topics today. So I'm going to give you a summary. So first of all, I have given you an overview of the framework to how to kind of test and verify the ADAS and AD system, right? So we have the environment model, we have the dynamics of the vehicle, virtual sensors, algorithms, driver models, human machine interfaces, etc. Right? And it's all about SORTIF and ISO 26262 to drive the kind of the safety and drive the how we should test the system properly, right? And to respond to the SORTIF, I have also introduced how you can design, simulate, and build a to build a scenario with RoadRunner. And I have also given a high-level overview on our ISO 26262 reference workflow with model-based design. And I also have given overview on different applications using AI and different tools, machine learning, and the deep learning toolboxes for creating the models, training the models, and to validate the models and run the models. Okay, so this is the summary of what this presentation offered.